my name is Lulu. I'm from Windhoek University Department of Computer Science, and I'm glad here and present our work. I'm going to present the recommender system, which based on our cloud-based electronic medical records EMR system, which is aims at our regional clinics and health center in China. My speech we're going to divide into 5 parts. I'll start with discussion with the background, and followed by design and results. In the end, I will draw a conclusion and give future work. Now let's start with the introduction with a background. Previously, our group has designed a clinic system for our university, which features in compact functions and which uses the local server and is capable of doing data mining. However, we find that for many of the regional clinic centers in China, they don't have the IT department to maintain their database. Therefore, we propose our second generation EMR system, which is a cloud-based EMR system. This is an overall flow for our clinic EMR systems. Basically, it combines the outpatient service and pharmacy management. Based on this cloud-based EMR system, we are able to propose our recommender system, which is my topic today. Our recommender system features in 2 functions. The first one is drug recommendations, and the second one is decision support in diagnosis. For drug recommendation, we are able to calculate the popularity of drug utilizations. For example, when hospital they are able to optimize their pharmacy stock, and moreover, because the circulating data, they may introduce drugs which has already been utilized where in other many hospitals. For the decision support in diagnosis, we are able to find the relevant symptoms to the disease. For instance, when doctors make the diagnosis decision, they may refer to our ranking, and then this may help to decrease the percentage of making mistakes in diagnosis. To talk more about our recommender system, I will talk about the system design. You can see here we have several hospitals database. They are individual. Are they isolated? Yes. But after they implement our cloud-based EMR system, the answer will be no, because all the database will return to our cloud database, and we will extract information without any private information to do our data mining side. Here is a sample table for our information extract. Okay, start with the data mining part. For the drug recommendation, we will have first the extract data we get previously and apply a parallel algorithm to do the data cleaning part. And for the selected data sites, we will apply association rules to find the association between disease and the drugs. Oh, sorry.
So how did you use the a priori algorithm for the data cleaning?
We will use the
A priori is the association mining algorithm. So how did you use the a priori algorithm for data cleaning?
Can I explain later?
Okay, sure.
For the decision support in diagnosis part, we will use symptoms as the input to apply the drug code index to compare the symptoms to our database to calculate the similarity between the disease and the symptoms. And then we are able to find out a ranking of relevant disease. To test the functionality of our recommender system, we have done some experiment in our lab. Previously, our group has summarized the disease frequency in our university clinics. The data is from 2013 to 2015. And we summarized the first 3 top diseases happening in our university for our testing. But due to the multiple medical institution requirement, we we generate the medical records for other 5 medical institutions and assign 5 drugs to treat those 3 diseases. After using our recommender systems, we are able to calculate expectation values for all 5 drugs and rank them from the highest to the lowest. And you are able to see here the ranking. Drug B has the highest popularity of drug utilizations, and C has the lowest. For the decision support in diagnosis, we are basically focusing on this part, on our own cloud-based EMR system, which is this part, and we test the examples with 4 input symptoms. And this system can give us support results, and we can see here pneumonia has the higher chance for the patients to get because of the calculate. In conclusion, our cloud-based EMR system are able to lower the cost of IT maintenance. So there are more regional clinics in China able to use that. With the many of the medical institutions using, where our system will feature in big data. Based on those big data, our recommender system will help the pharmacy to manage their stock and improve diagnosis efficiency. In the future, we will standardize the disease database along with the relevant symptoms and popularize our cloud-based EMR system, since we only have our university clinics right now, and improve present algorithm and the database so that we are able to handle huge amount of data, and develop some mobile-based apps so that we can get cloud feedback from our patients. In the end, I want to thank Dr. Zhang, who is the assistant professor in our Wenzhou King University Department of Computer Science, and Dr. Meng, who is the assistant professor in Wenzhou King University Department of Biology, Dr. Cai, who is the physician in Wenzhou King University, and the WKU students partnering with faculty research programs, Zhejiang Province Natural Science Foundation of China for the funding support. Now I would like to take some questions.